So we talked about this concept of loading sample onto a TLC plate, and we do that with a capillary tube. We put 1 or 2 spots of sample or drops of sample onto the TLC plate. We want to make sure that that spot is above the mobile phase when we put it into our chamber, so that way the sample can travel up the plate and not leach out into the mobile phase. And then we talked about this common problem that we would see down here at the bottom of too much sample itself after it gets developed. All right, so once I spot my sample onto the TLC plate, what then happens? What do I do with it? Well, the very first thing that I do is I put it into a chamber. All right. Now, there's going to be some background about the chamber first before I talk about putting the plate in there. The chamber is just going to be a container, and that container can be something as simple as a beaker. All right. Now, there are proper TLC chambers, and we'll talk about those in just a minute, and I'll show you some pictures of those in just a minute. But a beaker is perfectly okay to use. So a beaker would have some mobile phase in the bottom of it. So down here is going to be my mobile phase of this, or for the sample that I'm running. So that could be methanol, that could be alcohol, ethanol, that could be ester, that could be acetone, it could be acid, it could be base, it could be anything it wants to be, but that's my mobile phase. All right, so the first thing that I would want to do then is to take this beaker and put some kind of cover on the top. And the reason that I want to seal that up is because the mobile phase are typically very volatile, which means they evaporate very easily. And I want this whole container to be filled with vapor, because if I fill it with vapor, then my TLC plate will typically have a better time developing, and it will go much quicker when it develops as well. We want the plate to be saturated. So if I leave the beaker open, this mobile phase will actually evaporate out, and it could change my mobile phase composition. It also will not fill the beaker full of the fumes from the mobile phase, and that's kind of what I want. So I put a watch glass or a piece of aluminum foil or something over the top of that jar or beaker in this case, and I just keep all of that volatile fume inside so that my TLC plate can develop much, much easier. Okay, so some people will go through and they will add a very small piece of filter paper, or some type of paper at least. And that piece of paper will typically be here, and it will be stuck up against the sides of the beaker. And that filter paper will absorb the mobile phase as well, and it helps keep the fumes basically in the air. That's the purpose of that piece of filter paper or paper inside of my TLC jar. Some people do not use this though. They think that it interferes with the separation. They think that it competes with the TLC plate itself. They don't really want anything to interfere or create another variable inside of there. So they do not use a piece of paper at all, and they will just allow the fumes and the vapors to evaporate and be volatile on their own. And that's okay if you don't want to use one. I'm not saying that you have to. I'm just saying that there's an option out there for people if they want to do it. All right, so once I get ready to put my TLC plate in, then I will take this watch glass off, and that watch glass will have the mobile phase down here at the bottom of the beaker, and then I will submerge my TLC plate into the beaker or into the container. So I'm going to erase that line that I just drew, and I put my TLC plate down here in the very bottom. All right. Hopefully my starting line on the TLC plate is above the mobile phase line, and that's where my sample is spotted. And then I'm going to put the watch glass back on top, or the cover back on top of that beaker, so that way the fumes can stay in the beaker. And I want to do this pretty quick so I don't lose everything that I've basically led up to this point with, and it can start evaporating the sample from the plate. This process typically takes about 30 minutes. I want to prep my solvent container or my TLC chamber. I want to prep that for at least 30 minutes. Give time for those fumes to basically evaporate off and go up into the air and fill that container completely full. I take the watch glass off, put my TLC plate in there fairly quickly, put the lid back on so that way it can still stay saturated with vapor, and my TLC plate will slowly start to suck the mobile phase up into the plate to the very top. All right. So what do these sample jars or what do these TLC chambers look like? So here's a picture of what we would call a Coplin jar, C-O-P-L-I-N jar. A Coplin jar is made specifically for TLC plates, and this Coplin jar is basically a piece of glass most of the time, and there's a lid that screws onto the top, so that way you can saturate the Coplin jar full of the vapor and the fumes before you put your TLC plate on the inside. Now, the Coplin jars are kind of expensive because those are meant for TLC analysis, and it's a special type of jar. And then over here to the right-hand side, this is what we would call a chromatography tank or a development tank. And these tanks are basically made for TLC plates as well. So with the tank, it's very similar to the Coplin jar. They're typically made out of a specialized glass, and you would put your mobile phase down here at the very bottom. And then right here, this black thing that you're seeing in the picture, that's the lid. So the lid can go on top. It can allow the tank to fill up with vapor. I take the lid off, I put my plate inside, I put the lid back on, and then I'm ready to go. So that's an example of what we would look at as far as a traditional, accepted, prim and proper TLC developing chamber. And that's what we call those. But again, we can also just use simple little beakers in a laboratory for this process to work. Here's another kind of jar. It's not really a Coplin jar, but it's a jar with a screw cap lid, right? And that's really what these things are all about. So as long as I can keep my vapor trapped on the inside, my TLC plate develops a little bit better, okay? So again, a lid goes on, allow it to fill for fumes, take the lid off, put your plate inside, then put the lid back on, and allow this plate to develop from that point on. So again, it can be a TLC plate, it can be a piece of filter paper, it can be anything that the plate has to be. And then I've got some scenarios and some choices on what we call the chambers as well. It really depends on how fancy you want to get. Do you want to be Miss Prim and Proper and Sally SOP? Then you would use your developing chambers or your Coplin jars, and you would use your proper TLC plates. But if you're just doing this for an elementary school or a high school or a middle school, then a piece of filter paper and some kind of open plastic cup would probably be okay and work for you as well, depending on what you're using. So there you go. That's the scenario with the Coplin jar. Notice it says you got to place a top on the developing chamber, and the top can be a watch glass, it can be a cap or a cover, it can also be parafilm, and it can also be aluminum foil. The thing that I want you to keep in mind with parafilm is that parafilm does get eaten by certain organic compounds. So if your mobile phase has an organic compound that will dissolve the parafilm, then you do not want to use the parafilm because it's going to eat holes in it, and then what's the purpose of using the parafilm, right? If you're using an aluminum foil, the same thing goes. Aluminum foil can be reactive to certain organics. So you do not want to use those organics if you're using an aluminum foil lid. So prevent those reactions from happening, and you should not use aluminum if you know that that's going to take place. Sometimes the aluminum can actually burst out into flames. You don't want that in your TLC chambers, so you've got to be really careful with what you're doing and the proper method analysis that comes along with it. So just keep that in mind. These things are not universal. If you want something universal, then my idea is do a watch glass instead. The problem is that the watch glasses are made for certain shapes of containers. So, for instance, you can't use a watch glass on a rectangular tank because it's just not going to completely cover it up, right? That kind of makes common sense. So, let it equilibrate for 30 minutes, take the lid off, put your plate on the inside, and then put the lid back on as you develop.